Hey, welcome back. Today we're going to be talking about program design for ROBOTC software. First thing we're going to be discussing is behavior-based programming. What does? For example, turning a servo, reading a fan, turning a fan on, anything, simple types of behaviors. So there's three types of behaviors: a complex one, a simple one, and a basic one. Most of the ones that we're going to do are complex, but the main thing I want to remind you here is when it comes to your programming throughout this trimester, the simpler things can programs, hard drives crash, as all of you have come to learn with your computers. It's better. The less programming you can robots have to have, the product you're going to get. Here's a key concept right here. Complex behaviors can always are then broken down into basic complex behavior. A fan will run until someone needs it to stop. A safety device warning light will come on before the fan turns on. Another light will indicate that it's stopped. That'd be a very complicated system. Creating pseudocode comes from simple actions. These simple actions, describe them with short phrases. Example: turn a motor on for 3 seconds. Follow a line until running into a wall. Very simple. We want to describe when we're creating our for our programming. We want to describe what we want them to do. Here's kind of this process. First of all, we want to break each complex behavior down into simple behaviors. List the behavior line by line in that order each should occur. Describe the action, what prompts each action to continue. An example of pseudocode is the way that we're going to program our robots. Example: warning light comes on before the fan starts for 3 seconds. Turns on and runs until a button is pressed. A different light comes on for 3 seconds before the stops. It's important that we're very specific. Now, this is not going to be what tells the computer. The computer will understand what we're saying. What we're telling us is you're writing basically your own notes for what you're going to have to write a pseudo statements. The last step here then is break each simple behavior down into further basic behaviors in terms of what each input and output component will be. The simplest thing you can possibly break it down into. The example of creating program begins. Light 1, which would be the LED 1, turns on for 3 seconds. Turns on until a bumper switch, until a button, which is the bumper switch, is pressed. Light 2, which is the LED, turns on for 3 seconds, and then the program ends. This part right here, where it says LED 1, motor 1, bumper switch, is pressed, and then it says LED. We know it as light 1, we know it as fan, we know it as light 2, but we're going to know what we're telling. What we're referring to right here is what we tell the computer light 2 is called. What we tell the computer fan is called, what's called motor 1. This part here we will have already done by this point. You will have started working on it, hopefully finish this. Inputs and outputs. Identify inputs and outputs. We understand where you lay time. Identify where you put the schematic that will allow you to go back and look at for reference when you're programming. It's going to be a lot of bugs, and you're going to want to. This is going to be one of the first. Okay, now we're going to get into the meat and potatoes of starting to do some simple programming. Open sample. The first thing you're going to do is switch complex behaviors as your overall task description. Right at the top is what we're talking about. It says task description. Run until someone needs to stop. There will be a warning light before the fan turns on another light to indicate that it stopped. Now, this has to do with the program, but the computer's not going to look at this. Okay, this is what we got to do. You're telling yourself to get the computer to. All right, so it's a task description. Then the next thing, copy the pseudocode, basic behavior code section on the PLTW ROBOTC program template. Pseudocode. All right, and as you can see, light 1 LED turns on for 3 seconds. Motor 1 turns on until the button, which is the bumper switch, is pressed, which we've talked about. This right here, again, this right here is not telling the computer what really cares less what's up here. This is for you. You're starting to, now what we're going to do with the pseudocode, each line of the pseudocode brought down here into our task main. We're going to get more about that now. Okay, up here they're telling you to check all of your inputs and outputs, which we would have worked already in class. What they're through and check to make sure that input and outputs in the motors and sensors setup window are working correctly. And what we do is we debugger to confirm that all inputs and outputs are working as expected. About that in class. Okay. Programming. Motor 2 for 5 seconds. How would we get motor 2 to run for 5 seconds? Well, what I don't like about this is they haven't filled out their top bit of information. They haven't given us a task description. What we have down here is a start motor. Right here they're saying motor. You have to tell the computer, well, what motor to start. No, I can't read your mind. And then over here you're basically telling it which direction and how much power. Here they're saying you want the motor to run for 5 seconds, and that's why I'm saying once we've started, keep running for 5 seconds. That's what wait means. It means keep running for about 5 seconds. Stop motor. Well, again, you automatically know that it's the right motor, so you have to tell it to stop which motor? The right motor. A couple things I want to point out to you here. Everything that's after the double backslash will go green in these comments. The computer does not pay attention to this part here. The comments, again, for you to allow you to easily understand what's happening. I would write down some notes here about this. This right here is going into a lot of detail. I'm going to point out to you here. It's important. Task main defines the main task of the robot. All right, so this right here is telling us this is the main task main. That now is programming. All commands be task main must be in between these. All right, so we have a curly brace. That's one of the main things you guys forget quite often is to put. Always check that. That's your first thing. Make sure they line up. And then everything is programming. If you remember, right underneath the description, they give us pseudocode. Call these comments. It allows a programmer to very quickly find out, is my programming LED on? It's labeled as LED. My pseudocode telling me, or my comments, that I wanted an LED one to turn on. Well, that's going to be off for 3 seconds. LED off. Which LED? What did I want? LED one turned off. So this is a way of being able to beneficial. A lot of you will really fight this, and it's one of the most important things to do. last thing I'll leave you with. When it comes to testing your program, you're going to have lots of bugs throughout the course of your program. Frustrated at times. What you want to do then is test one part of the program at a time. Does this simple part work? The rest of the program off. Well, how do we do that? Right here it tells us a backslash and a star and a backslash. And what that means is that between that is turned off. So here, done is right here the backslash and star, and this star and backslash. Turn this into no longer being programming. They're turning part of the program off. The computer only knows to start right here with this part of the programming. What this does is it allows you to focus on simple behavior, one simple part at a time. And what that'll do then, it allows you to focus on a concentrated area. Instead of looking at the whole problem, now breaking it into smaller parts and trying to find out, are there any problems with the small parts? Well, hey, I'm going to leave you with that. I'll catch you guys on the flip side.